Alright, so now let's get involved in section 5.1, where we're going to talk about finding the inverse functions of linear functions in particular, but we're also going to talk about inverse functions in general. Alright, so let me give you an example. Suppose an employee is paid $10 per hour. Let I, income, equal f of t, a function of time, be the employee's income in dollars for working t hours. Now, up until this point, what we've done is we've created a function f that would send your hours, which is your domain, your inputs, because it's inside the parentheses. Remember function notation. If it's in the parentheses, then that makes it the independent variable, right? Okay, so if that's the case, then we would make a function that would take input hours to income, right, which is your range, your y values. That's what we've done for chapters 1, 2, 3, and 4, although they weren't always linear, but that's what we were doing. But the thing about mathematics, and I don't know if you ever realized this, is that mathematicians always want to be able to undo anything that they do. So for example, when you're a child, you learn adding, and then the next thing you learn is subtraction, right? Takeaways. Exactly, right. Why? Well, because the two of them go together. And there's some mathematical reasons for why that is, but we can get into it. And then the next thing you learn is multiplication. And then right after that, you learn division. Why? Well, because they go together. And the trick is that they're inverses of each other. I mean, we don't really teach kids that explicitly necessarily, but that's what they are. I mean, you learn that, I add on and then I take away, right? They're opposites, they're inverses. And then I multiply and then I divide, they're inverses. So we want to be able to find more inverses of more complicated functions. We're going to do some linear ones here, and inverses are going to be a little bit strange. So what they do is they go in reverse, right? So instead of taking hours to income, they'll go backwards. That's what the pink arrow is showing. They'll go from income back to hours. Okay? So an invertible function, f, would have the following things happen. If f of a is equal to b, then f inverse of b is equal to a. So I know it seems a little crazy, so let me give you an example here. Let me type it in, hold on. If we look at our income example, let's say it says f of t is your income, right? So let's suppose that you want to know the income for when you work, I don't know, 7 hours. Well, according to our rule, it'd be $70, right? Because, oopsie, I could type, right? So you'd say 7 hours, that's time, gets you $70. The function f takes the hours and gets you dollars. Then the inverse function, which is abbreviated with this little f -1 thing. The way we say that is f inverse. That's what that means. It doesn't mean -1, it means inverse. It would say, hey, if I take the inverse of $70, that's going to be 7 hours. They're opposites of each other. So f takes the input of hours, gets you dollars. The inverse function then takes you dollars and gets you hours. And that's what this box is telling you happens. That inverse functions, oops, hold on. There we go. I'm going to put it over here. So that's what they're telling you in this box, and this is just an example. But it says, hey, if you've got a function a or function f that sends a to b, then the inverse function sends b to a, and that's what he writes down here in words. Okay. All right, so let's take another example. Suppose I had a function where f of 5 was equal to 7, right? So think about what that's saying. That's saying it's sending 5 to 7. Then the inverse would go backwards. Hold on, let me draw a picture. There we go. All right, so here's 5, which is our x variable, if you will. See, there it is. And then it's saying, okay, f of 5 is equal to 7. So I say, okay, then I have 5 as my x, and the f function takes it to 7. Well, then the inverse function, f inverse, would take 7 and go backwards and get you 5, right? Which is why f inverse of 7 is equal to 5. Let me write it out. Okay. It goes reverse, right? And again, the diagram for it is right here. I'm going to make it a little bigger. Hold on. There we go. So 5 goes to 7 in the front direction. So in the backwards direction, the inverse direction, 7 goes back to 5. All right, so let's take that same principle and apply it to a table of values. So here I have x, all my different x's, and they're going to all these different y's, right? Okay, so then what would the inverse function do? Well, the inverse function kind of reverses the whole process, and there's no reason to have this here, so hold on, make this all black. There we go. Okay, so what would the inverse function do? Well, it would go backwards. You'd say 74 goes to 6. And you'd say 68 goes to 7. Generally, we would put these in order, but you don't have to. 60 goes to 8, and 52 goes to 9, and then 44 goes to 10. The whole reversing thing means that your tables are going to flip-flop, right? So let me drop a table for the one we had above. Hold on. There we go. I know it kind of nudged things over, but you can see it was taking 5, sending it to 7, so then the reverse would take 7 and get you back to 5. So it causes the tables to flip-flop. And that's what's going to happen down here. Your whole table flip-flops over. What was x now becomes y, right? And then what was y now becomes x, right? I'm going to color code them here. Oh, that's terrible. I'm sorry about that color choice. We're going to have a blue. There we go. Okay. All right, so if that's the case, then let's look here. We want to find f of 8. Now notice the function name. It's saying function f. So that means I want to look over here on this right-hand side. And it's got 8 inside that parentheses, so I must be talking about this one right here, which means I must be talking about 60. I'll put a little box around it. Now, what about f inverse of 44? Okay, well, see, it's got the -1 on it. See that little -1? That's a symbol that you're talking about the inverse function, which means I'm going to be over here on this, this left, right-hand side right here. So it's saying f inverse of 44. On second thought, maybe it'd be easier if I color-coded these ones. So let's see it that way. So this one's talking about the yellow one, but this one down here is actually talking about the blue function. See the difference? Hopefully. There we go. So f inverse of 44 must be equal to 10. Because when you look on the right-hand side function, the blue function over on the right, then it's equal to 10. All right, now let's see if we can apply this without having to make this whole separate table. Now you can make the separate table, but you don't have to all the time. So let's look here. So I've got find f of 6. Now notice this is a table that's already of function f. So if I want f of 6, I want to just look right here at 648. I'll highlight that one in yellow. Okay, so that means that I want it's equal to 48. And that's my answer. Let me highlight this for you so you can make it clearer. There we go. Okay. Now this one isn't talking about the same thing. It's saying f inverse of 6. So because it's got that -1 thing, it's not 48. It's not the same question. It's actually saying, hey, x isn't 6, y is 6, right? For the original function. So that's talking about this guy right here. So you'd say f inverse of 6 is actually 3, right? Because it goes backwards. Now, if you don't like that, if you find that kind of tricky, what you can do is make a new table. Hold on. Insert some columns over here. So you can make a whole other table with x and f inverse of x. There you go, if you were so minded. And you could say, look, okay, it went 3, 6, 12, 24, 40, 48. And then it went 2, 3, 4, 5, 6. So you can see right here, it's the same blue, it's the same row. That's why, right? 6, 3, right there. There it is. So f inverse of 6 would go to 3. Right? You can see it here because it's backwards, or you can see it here because it's frontways, because this is already the backwards table, right? You've already flipped everything for this f inverse table. So either way you want to see it, it's got to be 3. And then the bottom ones are right down here. 6 went to 48, straight up. All right, so now we've done it with a table form. We've done it with just kind of writing it, and then we kind of made up a table and saw some diagrams for ourselves. We looked at this double-sided table. We looked at this single-sided table and realized we could do it without making the double-sided table. But if you want, you can make that other half of that table. It's really a whole nother table. So if you desire to, then that's fine. And now we're going to do it with a graph. Okay, so this is the graph of f. Okay, now you don't have a table on this one, so you're going to have a little bit more work here. So you've got your graph of f, and you're supposed to find f of 3. Okay, so that means that x is 3, and you're supposed to find y. Right? That's the scientific notation, the function notation that we learned in section 1.6. So you're just reading a graph. You say, okay, when x is 3, so you go on the x-axis, 1, 2, 3, there's 3. You go up to where the y value is, and you go back and realize it must be 8. So f of 3 equals 8. Oops, and then I put that dot in so you could see it. So 3 goes to 8. All right, now let's see here. What about this one? F inverse of 16. Okay, well, this is doing the opposite, right? It's telling you that in the function f, y is equal to 16, x is equal to what, right? Because it's an inverse, it goes backwards. So that would be the dot up here on the top. Poof, there it is, blue. Okay, and so that would mean f inverse of 16 is equal to, okay, so you go to where y is 16, you drop down and realize it must be 4. Let me color code those so that way it makes it a little easier for you to figure out. This is talking about that red dot. So you're saying, okay, when x was 3, y was 8. And then this one's talking about that blue dot. It's saying when y is 16, x is 4, because you're going in reverse because it's talking about the f inverse function. Oh, this is giving me such grief. There we go. Oh, it's not the same color. That's okay. If I made it the same color, it'd probably be illegible. So, all right, we're done with that. And we don't have time to do the next question, so I think we'll just stop right there. So realize that the way this worked was because this was the function f, right? Since you're looking at the function f, you have to do this blue one right here backwards, go with the 16 and 4. If you were looking at the regular function of f inverse, then that's a different story, right? But because you're looking at the function of f, you have to go backwards for that blue one. All right, I'll see you back here for the next thing, which is graphing inverse functions, and we'll deal with that next time. See ya.